Hello everyone. So today we are going to talk about when we apply a classification algorithms and when we build a machine learning model, any classification algorithms we pick to solve that problem. And that can be a logistic regression as well. That can be a decision tree or any other classification algorithms. So once we build a model and we check the accuracy, and there are some more things required to evaluate that exactly the same that we did for the regression. For example, the RMSE, R square, we evaluate using some evaluation metrics. Either that problem is a regression one or the classification one. So today we are going to talk about the evaluation options that we do have for classification, and the one option that I am going to explain, that is confusion matrix. So you must, while creating machine learning models, you must have created or used sklearn metrics to build the confusion matrix. We imported and something similar to that what you can see on my screen or something like that. So what basically confusion matrix is, so that to discuss is the very first thing, that confusion matrix is just like a cross tabulation table, like the cross tab table that we build from pandas cross tab function as well. We call it contingency table as well, or basically the error matrix. Why we use it? Because we just want to evaluate that how many time our model was confused when it was making predictions. So it classify that issue, and it help us to evaluate or to further reduce the errors in that model. So today, in this, as name says, that confusion matrix is basically that how many time that model was confused while making the prediction, and we can accurate it further or find out some other way to make it more accurate. So the confusion matrix, we call it a contingency table or error matrix as well, which help us to visualize the performance of a classification algorithm that we applied. And in a very layman term, we can call it like the confusion matrix shows us the way in which your classification model is confused when or while it was making prediction for us. So this is the example that we are going to use here. In this example, I have taken two parts. One is the true state. True state means the actual scenarios, and one is the diagnosis state, I mean the predicted cases. Let's say I have the data in which I know the actual states as well, and why I have applied the machine learning model, the classification algorithms have applied, and the result that model given to me. So that I have put it that in two forms here, in which this diagnosis here shows us the predicted outcomes, and true state is basically the actual instances or the actual cases. So in this, what we can see into this contingency table, the true state was that person was not having cancer. I'm talking about the very first row here. And for this, no cancer, that means actually that person was not having cancer. And when we applied a machine learning model and we did a classification and we checked that it was diagnosed as no cancer as well. That means actual state was also correct, and while predicting, it was also correct. So we call it a true negative here from this, and it can be a vice versa as well. We can take the predicted case as a row and the true cases as a column as well. Here I have taken true states as a row and the predicted or the diagnostic states after applying the model as a column. So the very first case, we call it, whatever the value we get here, we call it a true negative. True negative means, for example, we get 10 here. So the 10 means in all of the cases, in all of the data, the 10 times the person was not having cancer, and we predicted it as not having cancer. I mean, not having cancer, that means the model was uh, not confused while giving that decision. Model was quite accurate, and model also says that person was not having cancer, and we call it a true negative state. And the other that we see here, that these are these short forms. FP is false positive. What false positive? Basically, the true state is the person was not having cancer, and the diagnostic state or the predicted state was person was having cancer. So in this case, the person was not having cancer. We did some analysis, and we applied and the algorithm, and we predict that person was having cancer, and we call it a false positive. False positive and false negative both can be very dangerous. Here you can understand the scenario. Let's say person was not having cancer, and you have given the all the medicines after predicting it that person was cancer, and they may uh, give a negative impact on that on the person's health. So that is also dangerous. Again, the next case is in the second row. We can see the true state was cancer. That means the person was actually having cancer, and when we diagnosed it, it was diagnosed as not having cancer. So that false negative, we call it false negative. False negative is also dangerous, because let's say the person was actually having cancer and you diagnose that not having cancer. So you don't give the precautions, the medicines and all, and the person may die. And this can also be dangerous. Both cases can be dangerous. So false negative is the one when the actual state was person was having cancer and you diagnosed was that as not having cancer. We call it false negative. And the true positive was the person was having cancer and you diagnosed as a cancer patient. So you were accurate to the true state and the predicted state two times. One was the true negative, where the actual state was no cancer and you diagnoses that as no cancer. That means that is actual state, the true state, and that is TN. TN means true negative. And true positive is also the case where in both way, the true actual and the predicted case, the person was having cancer and your diagnosis or your prediction was actually correct, that it was not having cancer. So you can see that we have two correct cells here. One is TN and one is TP. So in confusion matrix, there are two types of cells. We call them correct cells and the error cells. So the correct cells are the true negative and true positive one, and the error cells are the false negative and false positive one. So the false positive and false negative was the state where model was confused while making prediction. And if we do the calculation and we want to check the accuracy, we can add the all values and divided it by the number of occurrences so that we can get that output as well. So here I have put it the basic definitions of TN and TP, FN and FP. So TN is basically true negative. These are very important. True negative is the number of true negatives, basically the patient who did not have cancer, whom we correctly diagnosed as not having cancer, and that is a true negative state. What is true positive? So true positive is a state where the patient who did have cancer, whom we correctly diagnosed as having cancer. That means we are correct in both the cases. So true negative and true positive, we put them into the correct cells. And what are the errors? Errors are the false negative and false positive. What basically false negative does? False negative, when person who had a cancer and we incorrectly diagnosed is not having cancer. So that is also a error. That means that's a false negative value. Another one is the false positive. False positive is a case where person did not have a cancer and incorrectly we diagnosed as having cancer. So we can see what are the correct and what are the errors here, and we can easily understand the basically the meaning of TP, TN, FP and FN. This is also very important. Apart from this, while calculating these values, true negative, false negative, true positive and false positive, it is required, and sometimes we evaluate the model based on their precision and recall. We check the precision and recall basically the score, what exactly the precision and what exactly the recall. So precision is basically the proportion where the proportion of patients we diagnose as having cancer actually had cancer. Precision is the one we can I can give you some other states of precision and recall as well. Precision tells you how much junk there is in your predicted positives, and recalls tells you how much of the positives you can find. So basically what it happens, just to understand precision and recall, I'll be telling you one example. For example, that you are sitting with your friends, and what happened, your mom calls you up, and your mom says, whatever your name, let's consider your name as Raj, that hello, you need to bring these 4 items. So while talking to your friends, you somehow was not focusing what your mom was saying at that moment. Then you done with your meeting with your friends, and you go to the market and you try to recall what your mom was saying. So somehow you recall that your mom was asking this list of items that you need to bring, and you finally bring 5 items, and you were very happy when you reach home that this time I didn't make any mistake. I have taken all the items what I supposed to get. So once you reach home, you ask your mama, and your mom says that I asked you to bring these 4 items, but you have taken 5 items. 4 was the one which she asked you to bring, and 1 was extra. So what was your recall that moment? Your recall was basically 100%, because whatever she asked you to bring, you were carrying all the items. But at that moment, what was your precision? Precision is like how much junk you have added. So you have taken one irrelevant item while coming to the home. So your precision is not 100% at that moment. That is going to be reduced, but your recall is 100%, because whatever she asked, you have taken each and everything. But you have added one extra or one irrelevant item as well. So that irrelevancy is a junk, and based on that, your precision will be reduced. The percentage of your precision will be reduced. So that's a very basic example to understand that, like, recall is the one. It tells you how much positives you can find. I mean, whatever is asked you to bring or to predict, you correctly predicted that. But you have uh, wrongly predicted some other items as well. So that is, there is a junk. So precision will tell you how much junk there in your predictive positives, and recall will tell you that how much positives you have correctly predicted and you can find. So these two are very important to understand while evaluating the classification algorithms. You should be very clear what is precision and recall. And from this example as well, you can see, while we were understanding TP, FP, TN, and FN. So in that case, precision is like correctly predicted positive and the total predictive positives. Precision in terms of definition, it will tells us what proportion of patient we diagnose as having cancer actually had cancer. I mean, you were talking about the actual state. There was no irrelevancy, no irrelevant patient you have added as having cancer. But what is recall? Recall is a proportion of patient that actually had cancer, and it was diagnosed by us as having cancer. I mean, the accuracy, how many times you were correct. And precision is like you were correct, but you must have added some irrelevant things as well. So sometimes you say that we required precision is high, we required recall is high. So it depends on data to data. Here you can see this red part is the recall one, you can see, and the green part is the precision one. And these are, and in case you need to check the overall accuracy, and overall accuracy will tell you that how often the classification model was correct. So to calculate the accuracy, we will divide true positive plus, you will divide correct with correct and error both. So what is your correct? TP plus TN, true positive and true negative, that was your correct cell. And you need to divide that with entire data, your errors and your correct values as well. So this is how we find accuracy. So here I have taken one more example. You can see in this confusion matrix, just to give you more clear picture. We have actual classes and we have predicted classes. In this actual classes, we have two categories, male and female. And predicted classes, we are going to predict these male and female based on certain data using any classification algorithm. So the very first case, that was our TP, that was the true positive. True positive means like 42 times, that means the classifier correctly predicted a male person in 42 cases. But this is 8 and 18 was your error, but it wrongly predicted 8 male instances as female. I mean, the model was confused whether it's a male or female. So that have put it into the female category. But 42 times model was correct and 8 times model was confused. Exactly same, we go to the second line, second row, in which it correctly predicted 32 instances as a female. But on 18 cases, it was confused and had been wrongly predicted as male instead of female. So if you calculate the accuracy, what you need to do, 42 plus 32 divide by the entire data. And this is how you will be getting your accuracy percentage. And true positive, you easily understand that 42 is the true positive one. And this is your false positive 8. And then your true negative, this one, and your false negative, true negative, false negative. And these are the values that help us to calculate recall and precision. So this is how we basically calculate it. And sometimes people ask you untrue positive rate and false positive rate as well. True positive rate, we call it sensitivity, and false positive rate, we call it specificity as well. I'll take another video on these two examples. Now let's talk about two important concepts here. Why recall is important and why precision important. We are going to take these two examples here. So why recall is important? For this, the example is, suppose we have a weather forecasting device and we need to predict rainy days. If this device has a high precision, it means when it says it is going to rain, we can trust it. But this does not give us any information about all the time it says it's not going to rain. If the false claims us going to be costly for our business, that we might want to ask about the number of times this device miss a rainy day. That's why recall is also important. If our device keeps saying that it's going to rain today, I mean, it can be correct with all the times, but whenever it's not going to rain, it may also predict something that it is going to be rain. But this way we can have a lot of false claims, and these false claims can be costly for our business as well. That's vary from data to data and to domain to domain. And the other case is why precision is important. Like imagine our device is so stupid that is always claims that tomorrow is going to rain. Then surprisingly, it is not going to mispredict one single rainy day. That means recall is 100%. So should I conclude that this is a perfect device? No, I should ask for precision now. I hope you're clear with this. So our recall is 100% correct, but sometime it miss it, and it may add some extra days in which it was not rain, but it has predicted that this is going to be rain. So their irrelevant data is there. Irrelevant or false claims are there. So they can be costly for us. So that's why recall is also having their own importance while making decisions, and precision is also having their own importance while making decision. So again, I'm telling you, recall is like the accuracy, that how many times you were actually accurate, and precision is like how much irrelevant data you have added. For example, example that I have given to you, that your mom asked you to bring 5 items and 4 items basically, and you have added 5, you have collected 5 items and you reach home. 4 was the one that your mom asked and 1 was extra. So that moment recall was 100%, because you have recalled each and everything whatever she asked you to do. So 4 was correct, but 1 was irrelevant item that you have added. So your precision is not 100%. This is going to be reduced at that moment. I hope that's clear to you. So that's it for today. I'll come with some more interesting stuff in my next video. You keep checking the uh, previous sessions as well, so that you can interconnect it, and uh, we you can keep sharing your whatever the topics that you want me to explain in next videos in comment box as well. Thank you everyone. Take care, guys.